Hello everyone, welcome back to another lesson in this machine learning fundamentals series. This is scikit-learn part 2, where we're going to be taking a further look at scikit-learn or sklearn, in particular pre-processing, validation and pipelines. So why does pre-processing matter? Most machine learning models work better when the data is properly scaled, cleaned and what is known as encoded. Pre-processing ensures your models learn accurately and fairly. Okay, so we have what is known as standardization standard scaler, and we import it like so. So we're saying again from sklearn using this method, the pre-processing method. So we say dot pre-processing, and we want to import the standard scaler. Okay, so what does it do? It scales features to have a mean equal to 0 and a standard deviation of 1. So why is it useful, or when we use it? It's essential for different algorithms such as the k-nearest neighbors, nearest neural networks and SVM for example, and prevents features with large values from dominating the model. Okay. So different encoding categories. Okay, once again we import using from sklearn dot pre-processing, so it's a pre-processing method once again, and we're importing the one-hot encoder. So it's for models to understand categorical data like red or blue. We then use encoders. One-hot encoder turns each category into numbers that the model can work with, so it understands what each is. So red, for example, could be equal to 0, blue equal to 1. Alright, because computers, they understand things in numbers. So encoding is essentially taking text and putting that or mapping that to a number. Okay, so here's another example for find categorical columns like color or country. We apply one hot encoder, so this transforms the categories into binary columns, like in this picture up here. And then we can then use it in the models, so the models can now understand the categorical features. Next, handling missing values. So we will use the impute method and we'll import the simple imputer. Okay, so if your data set has missing values, you can fill them in using what is known as an imputer. So for example, you can fill in missing ages with an average age. Okay, so we can use a mean strategy, we can use a median strategy, we can use a most frequent strategy, for example. So different strategies according to, or different averages according to the type of data that we're working with, and whichever is most convenient we can all do from the impute method. Next, this is how we train and test our data. So remember, we always want to have a train and test split. There we are. And again, cross-validation. So instead of one test, we want to do our cross-validation. So we split our data into multiple sets and test each part, giving a more reliable score than just testing once, right? So remember, we looked at before our k-fold cross-validation. And so this is how we would do that in a coding format. So from sklearn, we're importing the model selection method, and then we're going to import our cross-validation score. Alright, and so it's going to look essentially something like this. And so we're iterating, or we're breaking it up into 5 folds, indicated by CV equals 5. Okay. Next, we have something known as a pipeline. What is a pipeline? It essentially is a pipeline lets you chain multiple steps like scaling and training into one, so it keeps your code clean and consistent. Alright, so it's essentially like a pre-packaged form of training and testing our data. And so this is how we build a pipeline. So of course we're going to call the pipeline method and then just import pipeline. And so the pipeline scales the data, then trains a k-nearest model all in one object. So you can now call, predict and score just like any other model. Okay, we also have, once again, hyperparameters, which we have looked at in previous lessons. So hyperparameters, remember, are settings you can choose before training, like how many neighbors for case of nearest neighbors, for example. Choosing the best ones can make your model perform much better. So it's like the tweaks that we do, right? Pardon me. We also have something known as grid search V, which we import from the same method, model selection, and then we're going to import grid search CV. And grid search CV, it tries every combination of hyperparameters and essentially picks the best one using cross-validation. It's a great way to optimize our models. Okay. And then finally, we have an evaluation. All right, we want to test to see how accurate our model is performing. So after tuning, we do a final evaluation on the test set. We use tools like accuracy, a confusion matrix, precision and recall to check how our model is performing. Then we then save our best model for reuse. Okay, so just to wrap up, we now know how to clean and scale our data, or understand how to clean and scale our data, use cross-validation for reliable testing, use grid search to tune models, and build pipelines to combine steps, or at least we somewhat have an understanding of how these things are done. So now we're going to go over onto some practical examples so you can see properly how to implement each of these steps.